In this example, we will apply the ratio test to determine the convergence of this series. So remember, what we're looking at is the limit as k goes to infinity of the absolute value of a sub k plus 1 over a sub k. A sub k plus 1 means take the series that we have and turn k into k plus 1. So that's 7 k plus 1 squared. Watch your parentheses always when you do these. And 4 to the k plus 1. We've turned k into k plus 1. That's what it means to say the k plus first term. A sub k is just the series as we see it. 7 k squared over 4 to the k. And then we're going to see this over and over. At this point, this is a fraction over a fraction. So we multiply by the reciprocal. And so that's 7 k plus 1 squared over 4 to the k plus 1 times 4 to the k over 7k squared. And we ask ourselves, what simplifies? What simplifies? Notice that I have k 4's in the numerator and I have k plus 1 4's in the denominator. So I have one extra k, but it's in the denominator. So I have a 4 in the denominator. In the numerator, I could FOIL this out if I wanted to, but notice that this is 7 k plus 1 squared, and this is k squared. That's all fine. I'm not going to FOIL it out. Let's leave it like this, and we'll take care of all of the other stuff when we take the limit, which is the next step. So the limit as k goes to infinity of absolute value of a k plus 1 over a k is the limit as k goes to infinity of this. Again, the absolute value we can ignore here because there's no negative anywhere. 7 k plus 1 squared over 4k squared. Now what happens when we're taking the limit? We're looking at the biggest degree term in the top and the biggest degree term in the bottom. If I were to FOIL this out, this would be a 7k, this would be k squared, and then a 7k squared. So that's 7k squared. That's the biggest term in the numerator. The denominator is just 4k squared. And so that's the biggest term in the denominator. The k squareds will cancel, and the limit is 7 over 4. When the limit is bigger than 1, it diverges.